So first, I'd like to introduce one of my first keynotes, Dr. Ronald P. Uhlig. He is the chair of the Department of Engineering at National University. He holds a bachelor's in science and physics from MIT and a PhD in physics from the University of Maryland. Dr. Uhlig has 19 years of experience in academia in roles such as the Dean of School of Business and Management, program director for the BS in computer science, and chair and academic program director for the master's in wireless communication. Dr. Uhlig has been awarded an incredible list of awards that do not fit in the slide. I took some samples. He has won the National University Distinguished Teaching Award in 2016, the gold medal for international telecommunication, the gold medal from the International Telecommunication Academies, the silver core from the International Federation for Information Processing, Founders Award from the International Council for Computer Communications, and an Army Commendation Medal. And if you wish to know more, you can visit his bio at the nu.edu website. Our second keynote is Dr. Shatha Jawad. She is a professor in the Department of Computer Science and Cybersecurity at National University. Her experience is around 25 years of teaching in different roles, as well as more than 3 years as a software engineer. She has been awarded a UNESCO Fellowship for Information and Communication Technologies and is currently a co-PI for the Institute for Learning-Enabled Optimizations at Scale, which is a big grant that is running from 2021 to 2026. Her research interests are operation systems, system software, artificial intelligence, neural networks, fuzzy logic, image recognition, quantum computing, and computer science education. And you can find more information as well in her website. That is not that one. So I'll fix that in the slides. But welcome to my 2 keynotes. So let's go ahead and skip over here and stop sharing. There you go.
Okay, well, thank you for the introduction, and good morning and good afternoon. I'm on the West Coast, so for me it's morning, and I know some of you are on the West Coast and some of you are on the East and everywhere in between. So I'm going to get started. Dr. Jawad is also here with us. I'll get started, and then there are times when she will join us in her part of the presentation. The agenda, let's see, here we go. Okay, I'm not going to read all of the individual items here on the agenda, but just give you an idea where what we're going to follow, starting with kind of what we're talking about when we talk about generative AI. Some of the reactions that have come so far from around various parts of academia. And then we're going to talk about some work that we have done, actually having some of our students. We're going to be talking primarily about master's degree students, although we've had both bachelor's and master's. We also have doctorates, but we haven't yet had anything specific with our doctoral students. Anyway, their use of not just ChatGPT, it's broader than that, generative AI in general. And then we'll end up talking a little bit about using generative AI as a collaborator. So I suspect most of you have read a lot, and possibly many of you have even experimented with generative AI. It can create text, very well written text, as a matter of fact, but it can do a lot more. It can create audio, it can create images, it can do simulations, it can write computer code, and more. It's basically pushing technology into the realm of creativity, which is an area that so far we would say that computers haven't really ventured into. ChatGPT, Bard, which has been renamed Gemini just a week ago today. Google renamed it Gemini. have captured the imagination of many, and there are others as well, quite a few others. I'll talk about a third one a little bit later in our presentation. So the obvious question is, why so much interest? Where's all this interest coming from? Well, this is a forecast that was done by McKinsey and Company, a very well-respected player in worldwide, really. And they have forecast a huge impact of generative AI on productivity. One of their recent forecasts estimated somewhere in the range of $2.4 to $4.4 trillion annually on the world economy. So this is a big impact. And it's captured the attention of a lot of people. There are a lot of concerns about it. Some people are very concerned that it's going to do away with a lot of white-collar jobs. This is moving the impact of artificial intelligence beyond the blue-collar jobs that it's kind of threatened in the past into the white-collar jobs. And that's of major concern to a lot of people. This forecast by McKinsey says almost half, well, a third to a half of this forecast of $2.4 to $4.4 trillion annually, one third to one half of that is just in sales and marketing. And that's probably where many of us are already seeing it. Here are some of the business uses that were already emerging a year and a half ago. And this has only expanded since then. Creating text, images, and video for marketing, generating task lists, documenting projects, engineering projects, looking at code, even writing code. And Dr. Jawad will talk about some of the experiments that we've done with writing code and some of what we've learned. There are a lot of potential uses of generative AI in the legal area. And there are many potential uses in research and development, including in biomedical engineering, some very powerful possibilities. The ones which got the biggest attention initially were ChatGPT, which was released just in November, I think it was November 1st of 2022. So we're only talking about a year and 3 months ago that ChatGPT was released and began capturing the imagination of a large sector of society. DALL-E is another one. DALL-E was named for Salvador Dali, combining his name with the Pixar robot Wall-E. I'm sure many of you have seen the movie about that some years ago. GPT stands for Generative Pre-trained Transformer, and it combines artificial intelligence and machine learning. And basically, it can learn from looking at data, text data, and other data without any human direction. Now, it first has to be taught. So it has to be trained on an extensive set of data. These things are really costly to build. Microsoft alone has invested more than $1 billion. And one can guess that other major players in the field have invested comparable amounts of money. GPT-3, which was the one that was released, I believe, I can't remember if it was 3 or 3.5, that was released November 1st of 2022. GPT-3 was trained on 45 terabytes of data. Somebody did the computations and said that translates into 1 million cubic feet, a million feet of bookshelf space. So it's a vast amount of data, really an incredible amount of data. And GPT 3.5 is even more, and GPT 4 even more. I haven't seen estimates of how much data is behind GPT-4. Now, having said all of this, the algorithms are not perfect. The algorithms that generate the text are far from perfect. The outputs can be inaccurate, and they can also be inappropriate. They also can generate biases. They're being trained using text, and that text can contain biases. Here are some examples of three examples that are in the public domain, I believe, of images that have been generated by DALL-E. So the first one is kind of fun, a hamburger in the shape of a Rubik's Cube. And maybe this is a good one for the day after Valentine's Day, a young man falling in love with his computer. And then here's one generated. This is not a photo. This is a computer-generated image of a young woman. And I don't know about the rest of you, but I find that a little bit scary, that we can generate things like that. And I mean, those are just very simple examples. So as we said, biases can exist. Basically, it's reflective of any biases that may be contained in the data on which these are called large language models. Whatever's in there, that can end up coming out in what is generated by the large language models. It can be wrong, it can be just plain wrong, and it can do what's called hallucination. I'll show you in a few minutes some examples of fake references generated by a ChatGPT on a student assignment. Work is being done to put in filters to remove inappropriate responses, but that takes work and it takes time. So you really have to review very carefully what comes out. Obviously, the training data won't incorporate the norms and the values of any individual institution or any individual corporation, any company. Those you would have to add additional training data to put that in, and that may not be easy to do, may be impossible. One of the things that has caused already lawsuits is that generative AI can just plain plagiarize. It's trained on all this data. If it's trained on data that's copyrighted, it can basically play that back to you, and it may, depending on which system is being used, it may or may not tell you what the source was. Some of the systems now are allowing you to ask, where did this come from? So at least you can give some credit to it. And you may have seen in the press that there are some lawsuits about this already. Well, what about the reaction? What does academia think? Well, the reactions have been all over the place. The extremes are, that's cheating, which should be banned. And that was the initial reaction of a number of school districts, K through 12 school districts around the United States. I think school districts in New York and in Los Angeles both initially banned it. The other reaction, the other extreme is, oh my, this is the solution to all our problems. Everybody should use it. On the cheating extreme, one quote is, oh, you can't use it anymore to take home exams, or you can't even use it for homework. I mean, you can't give homework anymore because students will go to a large language model to get their answers. On the other hand, people can say, oh, it's amazing. It does better than the average MBA. And it has taken and been used to take and pass a number of exams for MBAs from major institutions. We tend, Dr. Jawad and I tend to think that take the middle ground and to think about AI and large language models as a partner. We know that humans and computers in general, and artificial intelligence more specifically, aren't good at the same kinds of things. So really, we think the most appropriate question to ask is, what kind of partnerships should we use AI for? What kind of partnerships should we use these large language models for? In wherever you stand, it really is important that the graduates from all of our programs have a pretty good understanding of how artificial intelligence works, and in particular, how these large language models work. Now, Dr. Jawad and I were co-authors with a couple of other people of a paper that we presented, that was presented at the last annual conference of the American Society for Engineering Education in Baltimore, end of June last year. And basically, we were looking at the question of, is it cheating to use these? Well, in order to answer that question, you first have to define rather carefully, what do you mean by cheating? I've put here a quote that was drilled into me many, many years ago, won't say how many, by my 9th grade world history teacher. She must have said this at least once in every class. This above all to thine own self be true, and it must follow as night the day thou canst not then be false to any man. This was written by Shakespeare in Hamlet. So there are a couple of things here. He talks about thine own self, and it's important to think about how students cheat themselves out of the skills they're going to need by taking shortcuts, including shortcuts such as using large language models. The other key phrase in here is any man. And that really refers to society being cheated out of skilled workers, workers who should have learned something that they didn't learn because they used a shortcut of some sort. So that's where we focused our investigation into the idea or the concept of cheating. So one of the first questions that everybody asks is, well, can't we just use detectors? Many of us already use detectors for plagiarism. We use Turnitin rather extensively in National University for detecting plagiarism. Is there something like that for generative AI? There are detectors that exist. Some of them work well. Some of them don't work well. We tried using one of them against the initial draft that we submitted for our paper presented last June at the ASEE annual conference, and it gave an 80% probability that it was original. We think the reason it generated such a high probability that it was generated by AI is because we did quote output from ChatGPT generated for some of the questions that were asked. And so it probably looked at that and said, well, maybe it is generated by AI. We didn't use AI to write it. I will state that categorically. But you have to be very careful about using these AI detectors. The problem is that any of the detectors that have been developed so far have a very high false positive rate. So if you are going to use this on a student's paper and it comes back saying positive, yes, the student cheated, about 9% of the time, that won't be true. And of course, accusing a student of cheating, having unauthorized use of artificial intelligence, that could have disastrous consequences on the student's life in general. We try to be really careful that if we say somebody that they cheated, that we really know that they cheated. And these detectors, the detectors that exist so far, can't really do that. So we did an ethical analysis of, is it cheating? And the conclusions that we came up with, we used two different ethical theories. utilitarianism, or greater good. And we use deontology, which is rule-based ethics. From the perspective of utilitarianism, we looked at both the individual perspective and the societal perspective. And I've really already alluded to this. On an individual basis, they cheat themselves because they don't learn what they're going to need to know. And from a societal perspective, they don't acquire the skills that they need to solve society's problems. From the rule-based perspective, once again, we said, yes, it is cheating if you use it without acknowledging that you've used it. Goes against the rule of individual pride from an individual based, and claiming that you've done work as your own that was done by a tool like generative AI, that's not acceptable from a societal perspective. So from these perspectives, from these two different ethical theories, yes, in fact, it can be cheating to use artificial intelligence tools unless you acknowledge that you've used them. Okay, let me turn now to all of this. I'm sorry, all of this that I'm discussing now is covered in the paper that we presented, that was presented last June at the ASWE annual conference. And we'd be glad to provide you with a reference to it or even with a copy of it if anybody wants to ask for it. Just well, I'm hesitant to say send me an email, but I will, but I'll try to respond to everybody if any of you want one. Anyway, we tried using ChatGPT on two different assignments in a course. It's a cybersecurity, master's degree cybersecurity course on network security monitoring and incident response. And so I'm not going to read this whole question here, but basically, this was a discussion board question for students in an online class. Describe how network security monitoring fits into the new paradigm of computing. And this chart shows a partial response. The response is really too long to put on a chart, although the paper does show the complete response from ChatGPT. But basically, it came back with some well-written and rather detailed response to the question of is this I'm sorry, the question that was put. Okay, so we went on now to another, we used it for another assignment in the same course. And it referred to discussion in the textbook of something called defensible network architecture. And the question was, post your thoughts on the concept of defensible networks. And this is, again, a partial response from ChatGPT. Pretty good response. Defensible networks are worth the effort for organizations that are concerned about security and integrity of their data and systems. Now came a rather interesting part of the response from ChatGPT, because we asked them to comment about, does their organization have a defensible network? So ChatGPT says, basically, I don't have an organization. I'm a language model, so I can't answer that question. At least I found it interesting that the large language models are sophisticated enough to be able to make statements such as that. And then it goes on with some more things. As I said, the response was much more complicated than that. Both of these responses were good responses. If you, as an instructor, didn't know that that came from ChatGPT, you probably would have given the students some pretty good marks for that. pretty good grades. ChatGPT generated a lot of information that students could look through. And already we began to conclude that one of the things that would help students learn more would be to ask them, take the key points that you've gotten from what ChatGPT gave you or what a large language model gave you and summarize those in bullet form. Now, there's a danger along with that. You can ask a large language model to do that. You could take that output from it, put it back in, and say, give me the key items in bullet form, and it'll do it. So you really, at this point, have to kind of trust that students will do that themselves rather than using the large language model. One of the dangers is that we found that ChatGPT can generate fake references. And in fact, on this particular assignment that I've just shown, it did generate fake references. It generated a conference proceedings that didn't exist. It generated a whole conference that had never taken place as part of the references. And unless the instructor goes and looks up every one of those references, you're not going to realize that that's not real. So that's an issue that we all have to be concerned with. I'm going to turn the floor over to Dr. Jawad to talk about this chart because she did the work with using ChatGPT to write code.
Yeah, sorry. ChatGPT excels not only in writing programming code, but also in providing comprehensive comments that explain the purpose of each instruction in the code. I decided to challenge ChatGPT by assigning it the task of creating a backpropagation neural network for XOR. Actually, this is one of the assignments in the machine learning and deep learning course. Prior to coding, students are required to design the neural. Students are required to design the neural network, determining factors such as the number of layers, number of neurons per each layer, and the activation function for each layer. ChatGPT successfully addressed all aspects and generated code with excellent comments. However, I observed that for complex programs, particularly those of considerable length, ChatGPT initiates the task but may not always complete it. Additionally, in certain situations, the provided solution may not be the optimal one. You can continue, Dr. Uhlig. Thank you.
Okay, thank you, Dr. Jawad. So these are some of the key findings that we mentioned in our ASEE paper last year. ChatGPT can generate good papers, good code, and good answers. So that can be a concern. We also looked at the efforts to ban the use of ChatGPT, and we came to the conclusion, you're wasting your time. You're not going to be able to ban it. Detectors aren't good enough to know for sure whether somebody's used it. So it's just kind of a waste of time. So one of our conclusions was that we really need to change our assignments. So we tried the obvious. We asked ChatGPT, how can we grade an assignment completed by somebody who's using ChatGPT? ChatGPT basically came back and said, no, that wouldn't work. It's not designed to be used that way. So fairly simple answer. Okay, let's just take a step back and look at this technology in general. Technology is kind of an amplifier. All of the things that have been developed over the last 50 or 60 years can be thought of as amplifiers. This is simply another new technology. I had a very good friend. He's passed on now, but he was fond of pointing out that exactly what this says, that the technology can be used for good or bad in general. There's no simple, there's no technology that's going to be used only for good. Now, we've kind of accepted that cheating is bad. By definition, cheating is a negative thing. And society is kind of obsessed with exposing cheating. And that's another discussion. I'm not going to go into details on that. But if we go back to what AI does as an amplifier, it can show different ways to express ideas. It can be quite creative, or it can help somebody be more creative. From an ethical perspective, machines don't have any morals. Basically, whatever might be in the code or in the training data reflects the morals of a particular system. It reflects actually the morals of the creators of the system. And machines don't have any world experience. So we really have to ask ourselves, if we're creating assignments that can be answered by AI, by generative AI in particular, are we really helping students learn? Now, there's kind of an interesting example that we can look at in this regard, and that is the invention of the handheld calculator. These calculators became widely available about 50 years ago. When I say widely available, I mean inexpensive, and handheld inexpensive. I know over the years, there was a period of time, maybe 20 years ago, where it was common for people to even mail you a handheld calculator as part of trying to get you to buy into something. There were a lot of objections to the use of calculators, these handheld calculators in the classroom. People cried foul, it's cheating. Students won't learn arithmetic. Well, the debate went back and forth for a number of years. Kind of the big change took place in 1994. That's when students were first allowed to use calculators while they were taking the SAT, the Scholastic Aptitude Test for college admission. And after that, there was more general acceptance of calculators in the classroom, basically because people came to the conclusion that the time that you saved using a handheld calculator gave more time for people to think and for more important learning to occur. So the question is, well, does this apply to large language models, generative AI as well? Yes, it is cheating if you don't admit the fact that you've been using them, but you are not going to be able to stop students from using them. So we came to the conclusion that we want to encourage our students to use AI as a form of collaboration, kind of you can think of it as a member of a small group project. The large language model is one of the members of the small group. And we felt that from an ethical perspective, higher ed should basically be looking at how should we be assessing student learning, and what should we do to try to use these large language models to improve student learning. And we said you should use it as a collaborator, but that collaboration needs to be acknowledged, and students need to reflect on what it is that they learned from using the AI. We said the best way to proceed is probably with this kind of the project-based learning assignments, case studies, and with hands-on assignments as well, exams and labs. I'm not going to, in the interest of time, I'm not going to dwell too much on this, But there are a number of reasons why AI can be a good collaborator. You can think of it as an extension of a calculator, but there's no one approach that works for everything. You can learn a lot from using AI. Basically, it should be okay to collaborate with a machine that you consider intelligent. But when you do that, you should invite students to reflect on what it is they've learned. So that means we need to think about how we're going to adapt the use of generative AI. And I'm going to show some approaches that we've used. Dr. Jawad and I are going to show some approaches that we've used now in a couple of places. One of the things we've done is in the syllabus for the course, we actually encourage students to use generative AI. I've extracted the bullet points on this chart from a real syllabus in a course that I teach on, it's called Security in Computing. It's basically a cybersecurity course for our Masters in Computer Science students. So we said it's a great learning tool. If you just copy and paste, that's plagiarism. You're gonna be penalized for plagiarizing. You need to, if you quote from an AI response, you need to put in a citation. Interestingly, APA, which is one that many of us use pretty widely, the APA style has published a guide that says, here's how you cite the use of ChatGPT in an assignment. So we put that into the syllabus, tell the students go there, learn how to cite that reference properly. But you also need to be aware that large language models may make up things that are not, may call things facts that aren't facts. You also need to, well, one of the things you could do is use AI to edit your work. But we said at the end, don't cheat yourself. Basically, I've talked quite a bit about that already. So let me move on. So assessment can be a challenge. So one of the things that we're starting to encourage students to do is to use what has been dubbed prompt engineering. Responses from generative AI turn out to be very heavily dependent on exactly the exact wording of the prompt that is given to the generative AI model. Minor changes to those prompts can produce very different responses. And the name that has been given to various approaches to developing the exact wording of a prompt, it's being called prompt engineering. Now I'm going to go quickly through a project that I gave to students in this security and computing course. And basically, the question for this project, student project, was, what's the impact of generative AI on cybersecurity? We gave them some guidance. Review recent news articles. We gave them some references. Develop a list of potential good and bad impacts. And ask about impacts from multiple perspectives. For example, how does it impact management? How does it impact customers? How does it impact society in general? Those are three possible impacts. So the students came up with a set of pros and cons. First of all, positive impact and negative impacts. And I'm not going to read all of these in the interest of time. I'm not going to read all of these. We have submitted a paper which is going through the review process for the next American Society for Engineering Education annual conference, which will be in Portland, Oregon in June of this year. And hopefully we can share that with anybody who may be interested. So they generated a list of pros and cons. And then the students went ahead, and the students did this on their own. We didn't tell them they had to do this. They tried using their prompts with 3 different generative AI systems. One was ChatGPT, one was Google Bard, and I think I mentioned earlier, Bard has, 1 week ago, Bard was renamed Gemini by Google, but the slides are all going to reference Bard because that's the way the students did it. And another large language model called Claude. So first of all, they asked each question using a separate prompt. Then they asked them all to get all the questions together in a single chat. Then they primed each system before asking the questions. They primed each system with some questions as if they were a novice user, a beginner, primed it with basic questions, and then they developed a set of advanced questions for priming the system. So these were the baseline questions that they asked in steps 1 and 2. Again, I'm not going to read all of these, but the initial question, how does generative AI impact cybersecurity? How does it impact from different perspectives? They also added a perspective government officials, and some more things. Interestingly, they generated this question, a third from the bottom: are you a threat to cybersecurity? And how can I use you to be a threat to cybersecurity? Followed by, how would you regulate yourself? So then here are the priming questions. As you see, the basic questions were simple. They implied that the users were a novice. The advanced questions were advanced cybersecurity questions. I'm not going to go into the details. The baseline question responses were much more detailed after the system had first been primed by asking these advanced questions. Basically, the large language models assumed the questioner had a better understanding of what they were talking about, and so they could go into more detail. With regard to the question about could the system be used as a threat to cybersecurity, the students discovered that there were some guardrails in place. ChatGPT and Claude said they couldn't respond. Bard started to respond and then changed its response and said, I don't understand the question. It was kind of interesting. Students then used a couple of questions to rank the quality of what had been produced. I'm going to go through these very rapidly because we're running late on time here. They ranked from the perspective of correctness, informativeness, and relevance. And you can see that there were some differences across the 3 systems. Please don't use these as a general indication of the quality of the 3 systems, because they're really highly relevant to the particular questions that were asked. Now I'm going to turn the microphone over again to Dr. Jawad to talk about coding assignments.
Yeah, we tried different approaches for the coding courses. It can be directly coding courses or some courses related to coding. So one of the approaches that we tried is brainstorm coding assignments to find solution for a specific scenario. In this approach, before writing the code, students should present their solution ideas by following a specific format, which may involve filling specific fields in a table and or preparing a 5-minute presentation to explain the solution. We used this kind of assignment in a machine learning course. Dr. Uhlig, can you go to the second approach? Yeah, in this approach, we provide students with a diagram, sorry, and ask them questions about this specific diagram. For example, instead of asking about the function that should be used for a specific output layer in a neural network, we can show them the required output shape. Similarly, instead of asking them to design a graphical user interface for a specific project, we can give them the design as a diagram and ask them to write the code for it. Following that, we can ask them to improve a specific portion of the design and write the corresponding code for the improvement. It is important to note that the intention is to facilitate learning rather than encourage direct copying of answers. This question format has been utilized in courses such as deep learning, topics in computing, and user interface engineering. Okay. Yeah, thank you. Also, one approach implemented in our Python course involves assigning a project for each subject, with students work on different segments of the code rather than requiring students to write a complete code for a specific problem. We break down the code into pieces. The project can be initiated during the lecture as a class activity, with some sections left to be completed as a homework. For those utilizing generative AI tools like ChatGPT, it is crucial for them to employ the same variables and parameters discussed in the classroom. Copying solutions from ChatGPT is not permissible unless students comprehend the code and updated it in alignment with the collaborative work conducted in the class. Actually, this method is not exclusive to Python courses or programming code courses. It is also applied in machine learning, deep learning, and various computing-related courses. The last approach that we will present today is group project assignments. In this approach, students are required to present either a research idea or a programming project. If the course is on-site, the presentation is delivered in person. For online courses, there are two approaches. The first approach involves organizing a Zoom meeting where students present their work and respond to questions. The second approach entails recording the presentation with their voices on each slide. Other group members are then expected to watch the recorded presentation and write a paragraph summarizing the content. Actually, this approach facilitates collaborative learning among students. These assignments formats have been successfully implemented in various courses, including machine learning, deep learning, Python, and other computing-related topics. The floor for you, Dr. Uhlig.
Okay, thank you, Dr. Jawad. So by using these approaches, we've seen that when they use generative AI to complete their homework, by structuring the assignment appropriately, they do attain the learning objectives for each course. So we feel that the evaluation of their performance does remain both fair and effective. So just, and I know we're at our time limit here, just some final thoughts. These tools, the large language models and related tools, they're going to continue to increase in power. They're going to be around. They're going to be used widely in industry. And we're going to need to adapt in higher education. It's probably too early yet for a full consensus to have developed, but more and more, we know that the people who will hire our graduates want to know that they know how to use these AI tools. So we better teach them. Some of the instruction in the future might even be shared with the AI tools, and maybe some of them will perform better in some cases. But the need for humans is not going to go away, ever. So those are just some thoughts. And with that, we'll bring this presentation to conclusion. And I turn it back to the chair.